is page 2 of the questions preparing for quiz for the quiz. So on number 5, given that f of x equals x squared e to the x, what is an approximate value of f of 1.1 if you use the equation of the tangent line to the graph of f at x equals 1? Okay, so we see those keywords. Equation of the tangent line. So we know we're looking for the derivative. So I'm going to find the derivative. I'm going to have to use product rule because there's 2 pieces. So just to keep myself straight, I'm going to call the first piece g of x and the second piece h of x. That would be g prime of x times h of x plus h prime of x times g of x. Now I'm actually going to find those pieces. 2x e to the x plus e to the x squared. So that's your derivative. Now I'm going to plug in 1 to find the actual slope of the tangent line. E plus e. So it looks like the derivative at 1 is 3e. So I need a point of tangency so I can make the equation of the tangent line. So I'm going to just do f of 1. It's going to be 1 squared e to the 1. So f of 1 equals e. So my POT is the point 1e. So my line is 1 minus e equals 3e x minus 1. And now I'm going to plug 1.1 into that. Y minus e equals 3e 1.1 minus 1. So y minus e equals 3e times 0.1. So that would be y minus e equals 0.3e. Y equals 0.3e plus e. So obviously if you're looking at this is my answer. I go over and I look at the answer sheet and they're all actual decimals, so I'm just going to plug that into my calculator. So on your calculator, I'm going to plug in 0.3. If you've forgotten where e is, it's down in the pi. If you hit the pi button down on the left hand side, e is there. 0.3e plus e. 3.534. So it looks like A. So your final answer is going to be A. Alright. Moving on to number 6. If f of x is 5 cosine squared pi minus x, then f prime of pi over 2. So the derivative at pi over 2. So the first thing we have to do is find the derivative. Again, you are going to be using, looks like product rule and chain rule maybe. So let's see. The first thing I'm going to do is rewrite it just to make this a little easier to look at. This is why I say chain rule maybe, because, okay, 5 is a coefficient, so it's going to go in front. I'm going to rewrite this as cosine pi minus x and then put the squared on the outside, because that makes it a little easier to look at. And then I can see that I probably do need to use chain rule. So I can say, now remember that I could use product rule in this case because I have a constant, but because of the product rule and the derivative of a constant being 0, I know that the second piece is going to go away and that piece that has the 5 in it is going to remain. So I'm not going to worry about that right now. I'm just going to do y equals u squared. U equals cosine W, and W equals pi minus x. So, my derivative at x is going to be 5, and then dy du, du dw, dw dx. Dy du would be 2u, du dw, negative sine w, and dw dx, negative 1. Okay, so now I'm going to go back and plug in all the pieces. I'm going to multiply by my negative 1. I'm going to multiply 5 times 2, which gives me 10. And then by the negative 1, so I should have negative 10. 2, and I'm going to plug back in u, which is cosine w, times negative sine w. And now I'm going to plug back in w. Negative 10. Oh, there's no 2, sorry. I already used it. Cosine of pi minus x times, negative sine pi minus x. I just realized I have 2 negatives, so I can cancel those. So now it's just 10. Okay, so do you see what I did? I multiplied my 5, my 2, and my negative 1, and got the 10. Just plugging back in what u was and what w is, and I realized I have a negative and a negative, so now my 10 is positive. Now, we have to find this at pi over 2. So I'm going to plug in, I'm going to change what color I'm writing in now when I'm starting to plug in. That way maybe it'll kind of keep it all straight. Okay, so now I'm plugging into the derivative, pi over 2. So I have 10, there's a bracket, cosine of pi minus pi over 2 times sine pi minus pi over 2. Alright, so that's 10 cosine pi minus pi over 2 would be, so that's a whole pi minus a half pi, so you get half pi, times sine half pi. Well, that means, let's see, cosine at half pi is 0, sine at half pi is 1, but 0 times anything is 0. So your answer is A. All that work just to get 0. Alright, for the next one, for what value of k does the graph of g of x equals k e to the 2x plus 3x have a normal line whose slope is negative 1/5? Okay, well they've given us the normal line, which means if I flip this and change it, I have the derivative. So I want g prime of x to equal positive 5. So I'm going to take the derivative of g of x. So remember, k is a constant. It's a value that we don't know, but it's a constant. So we're going to use power rule and just multiply. Kind of use power and chain rule, but so g of x is going to equal 2 ke to the 2x plus 3. And I'm going to set that equal to 5. Alright, now they told me x is 1, so 2ke to the 2 times 1. I subtract 3 from both sides. 2ke squared equals 2. Divide by 2. And I get ke squared equals 1. I'm trying here to get k by itself, so I'm going to divide by e over 2. And k equals 1 over e squared. If this was a multiple choice question, you would check to see if your answer is like that, and if it says an actual decimal, you just plug it into your calculator. If this was for your response type question, more than likely you would just leave it like that. Probably would depend on whether this was the calculator portion of the test or the non-calculator portion. All right, that's it. We'll do the next page in a separate video.